Hi everyone, thank you all for coming. Thank you all for coming and welcome to C++ Serbia community panel on how to modernize your codebase. So, to give the introductions, here are speakers and I'll let them introduce themselves. And before we dive in, let's start with basic questions. Introduce yourself, where are you coming from, and what's your position in your team?
Hello, I'm Jole. I've been a developer for 18.5 years, and I work at Nutanix currently.
Hi, I'm Petar. I work at Inceptive, and I'm one of the co-founders, and I'm responsible for the technical side of things with Dusan. I've been a C++ developer for the last 10 plus years.
So hello, my name is Nikola Jelic. I'm an embedded C++ engineer for the last 16, 17 years. I come from Čukić engineering.
I'm Ivan. Today I'm representing the open source community and KDE as my primary target, but I also work at KDAB, which is not the same thing as KDE. And I've been a contributor to KDE for decades now, maybe 2 decades.
Yeah, so let's start with you. So you mentioned KDAB and open source community. So what's the structure of your team? How does the team look like, and who are your users?
So again, I'm just going to answer as a KDE person, not as a proper software engineer. My users are people around the world, millions and millions, including CERN, some Hollywood studios, schools in Brazil, etc., etc. So a lot of people use KDE.
Yeah.
I'm currently working for a service company, so we have many clients. I work mostly with the clients in industry, like in agriculture, civil structure engineering, smart home, and so forth. That would be for short.
And what's the team size?
Depending, 1 to 20, depending on the client, depending on the longevity of the project, but I would say usually a handful. 3 to 5 would be a strike force.
Okay.
Yeah, so we primarily focus on creating an ultra-low latency exchange. So our users would be high-frequency traders. So they would actually be technical people writing software. And our team size is, depending on the time, between 3 and 10 people.
Yeah, so my company deals with hyper-converged infrastructure, basically, and the teams are per project, so per feature, and currently it's about 10.
Yeah, but like the entire code base is used by how many people?
Millions, I mean.
No, but how many engineers are working on the code base actively and contributing?
Thousands.
Okay. Yeah. So that's just for everyone to understand scale and the kind of problems people can be dealing with. So let's start with C++. What does modern C++ mean for you? Which standard are you currently on, and which standard do you want to be on?
Well, we always want to be on the I personally want always to be on the latest standard, but we are content with C++ 20.
20?
Okay, yeah. And what it needs to be like? I mean, it's performance and the ability to do anything with zero cost abstractions. Less code to maintain than C.
So, yeah. So is there a reason, is there a push for you to go to 23 or even further, or are you content for now to be on C++ 20?
Well, like I said, personally, I will push always, but it has like many dependencies, so it might not happen tomorrow, but I'm certain it will happen. The team that's responsible for that will do it eventually. Yep. I hope so.
Yep. So I would say modern C++ for me is not about the version. It's all the features, any feature that you can use to make your code chiefly the primary chief to be safe and correct. So two main chief goals: correctness and safety, and maintainability. So three main goals: safety, correctness, maintainability, and performance. And I'm going to stop quoting, paraphrasing Monty Python, but you get the drift.
Yeah. And what standard is the code base that you mostly work on fixed?
So in KDE, different projects have different coding standards. For example, the frameworks, the libraries that we provide usually require lower standards. Whatever Qt supports, we tend to support. And things like the desktop environment Plasma, it can go to 2023 depending on the desires of developers. And if we get somebody who is really, really, really annoying on the mailing list, then it gets pinged and bumped up to some newer standard.
All this is a bridge.
Yep.
So for me, currently hot version for me would be around 20. So also because I come from the embedded world, we tend to be 5 to 10 years behind whatever is going on anywhere else. So that's the baseline. And I might go on a tangent what modern C++ might be for me. So apologies for that. Actually, whenever I can compare one little C++ function to a verse in poetry in the sense of terseness and understandability, that's for me that thing. So if you could do it with C++ 98, probably, but let's say from 11 and then 17 and onwards, let's say the amount of poetry you can write, so these nice little nuggets that have some sort of cadence and beauty to it, really grew substantially, and that would be my guiding principle and why I would like to get a higher version or whatnot. Okay, I can compress this even more, and this is now even closer to how I would tell it to a human person. So that would be my...
And what's the feature from like that new standard that enables this? Can you single out one feature?
Well, one feature would be difficult, but two things to go with Ivan would definitely be, well, from the moment that we got the variadic templates, that would be one gigantic. And whatever you now can do with ranges and piping stuff, very similar to Haskell and other normal languages. So that would be like two killer features and many small cousins in behind crawling it.
Better.
Yeah. See, Holy Cousins don't know.
He's right, we come from civilized.
Yeah, so I would say that we are always trying to use the latest version, but realistically, most of our code base is probably C++ 17. Like realistically, C++ 20 is great, but it introduces many things, but nobody supports it in any capacity, so it's kind of worthless. Like, I mean, modules modules aren't yet supported. Concept came in too late to be useful. Everybody who really needed them just did them in some capacity, even ranges that you mentioned. And for me, it's more about language features. I don't care about libraries. You just write them out if you need them. So the major thing I would say that we got in like C++ 23 was deducing this. And that's my perspective.
Yeah, so you kind of see 23 as a skip standard, so to say, like
just deducing this is more than enough for me. Like, okay, it brings enough value.
Okay, so to you two, do you have some holdback by either your clients, customers, or by the community in regards to standards?
Well, as I said, because I come from an embedded world, code bases tend to be decades old. And like the moment when we got anything into C++ 11 many years ago was a gigantic leap. So in many cases, there is simply conservatism of the code base and also the existing developers. But from time to time, there is enough itch to be scratched. And then somebody says, oh, actually this entire line of problems is solved in C++17, for example, and within a month or two, voila. But that would be like simply the problem of gravity, like the mass of code which was already present in something in the older versions. If we write something from scratch or a new project, I would say C++20 would be now the go-to version.
For open source as KDE, a lot of people there are really enthusiastic, do it for yourself, people not paid by anybody, so they tend to be much more easier to work with concerning new features and learning new stuff. Obviously, there are dinosaurs, and we even have one name that appeared in several, let's say, decades of KDE with different versions. Surname 4, like the number 4, right? So, but even those people, again, they're enthusiasts, so they love what they're doing and they don't mind learning new things. So for open source, at least projects like KDE, I would say we don't have any problems convincing people that newer standards are better. The only limit that we have is the support, library support, if we want our libraries to be widely used by, let's say, commercial products.
Okay, so other possible deterrents for moving towards versions is tooling. So for anybody basically, and even you guys in the audience, like, did anybody have a problem with some of the tools like your IDE or some other tools that you work with that help you on your code base that don't support or are slow to support new versions, and that's why you had to hold off switching?
Yeah, I can start. Like, we're using Bazel, and Bazel still doesn't support modules. Like, I would love to use them. They're great. They're not supported. So that's a major example of it.
Yeah. Okay, now for you, Jolly. Your scale is much larger than what these guys are working with. So how do you deploy all of this code base? Like, how does your CI/CD pipeline look like to basically ensure that the modern stuff that you're adding remains there, or that the new code that is written is up to the newer code?
And how much time do you have?
Yeah, we do.
There's a lot of process in place to test everything. There's separate people that, there's separate tests for what we develop. So at the end, everything works. But primarily it's the test that the developers run to ensure that the code compiles and runs accurately. I mean, that's not that difficult, but the exact process, I'm not sure that the exact at liberty to say.
Yeah, but is there any tool that you use to validate the actual code written? So like modernization.
Yeah, client format is my preferred thing, and stuff like that. But it's writing the format, the exact format, because the code base is really old. It's kind of difficult. So, but it's possible, and then that can maintain your code. It's hooked on Git, so that's.
And do you use maybe Clang tidy to?
Yeah, Clang tidy. Clang tidy with Clang format. The whole Clang tool, I would say, package.
And if it's no secret, how long does that Clang tidy last?
I don't know. I mean, it's optimized some way. So, and like, I'm not sure exactly. Like, if you were to run it from scratch, and I don't know.
So are you generally satisfied with the tooling that we have in C++ at the moment?
We could do better. Like, I would love to see something that, for example, Python has like an official standard, and like, this is the standard, everyone should use it, rather than have Google standard and stuff like that. And then there are separate tools to enforce other stuff. So that's both the code writing style and the like accurate style. For example, the tests, I'm pretty much sure that the Google test is the standard nowadays, but something should be the official standard. I mean, would simplify life for a lot.
Yeah, I understand that. Nicola, what is your take?
So, I'm actually quite satisfied with the tooling, and as for the coding standards, I might be slight of a heretic. I never cared, like literally any, as long as it's readable, it's fine. So if people want to put brackets here or there, I'm completely blind to that.
So I will get what standard it is. I just care that it's uniform.
So that's fine. With that, I might agree. Like, if it's readable, like if it's every function is completely different naming and completely different casing, that yes, I would start noticing. But in general, I really don't care.
But do you guys care on things like whether const expr is used, or like this could be const expr, this could be const eval?
Sure, because the code is better that way and safer and faster and so on. But
do you guys use tools to enforce this, or is it more of a code review thing?
Tools, in some cases, not enough in my opinion, but it's hard to make a tool to enforce that kind of stuff. Because then you're taking away the liberty of the developer that the code may actually be correct and better that way. But if you, for example, say you can't use, I don't know, const expr, then you've cut off, or you must use const expr. So it's really hard to make a tool that will enforce const expr in the cases that it should enforce it. And I don't know such a tool.
Okay, I mean, Clang Tidy can perform a lot of these checks, depending on how many you enable, but then it lasts a long time, and that's the trade-off. There's also, like, I don't know if you guys follow like the C++ coding standard. What's the official name for the page?
Core guidelines.
Core guidelines, yes, exactly. Core guidelines. Do you guys follow that? Or in your case, in embedded, do you have any other standards that you must intrude?
we have the globally hated MISRA standard, which we tried not to use. No, I actually don't think we ever been so, let's say, standard driven. We were mostly feature driven, so I might as well now start reading the core.
But no. So I would say that core guidelines are perfect for majority of people. If you know better, then you know better. Yeah.
And what's your take on the general direction of C++ tooling? Does the new stuff that's coming out make the code more safe? And do you see the push from the committee as a good thing, or there should be more?
So I would agree with both completely contradictory opinions. There could be more. At the same time, I remember what C++ tooling looked like when I started using C++. I still use Vim and NeoVim, but NeoVim is now an IDE, and back then it was almost like Notepad with syntax highlighting. So tooling has become significantly better than it ever was. It's much safer with sanitizers, with everything. And obviously the committee is planning, they have that, let's say, tooling subgroup, and they also have the profiles proposal, which is meant, again, to be something to allow tools to do a better job, tools including the compiler, to make your code safer, nicer, etc.
Okay, so in the open source, what is your approach when there is a new developer that wants to come in? How do you onboard them to your way of writing code and the level of standard that you expect when somebody opens a pull request?
Okay, that's probably not the right question for me. A long time ago, I was caught saying, after I gave a talk at our KDAB conference, and people asked me, but what would you say if somebody doesn't understand the advanced C++ that you presented? My initial response, obviously I explained it later, was I don't care. And people heard me as, oh, he's one of those ivory tower bastards. You can beep it out in the recording. He doesn't care about people, etc. My point was, if somebody comes to, let's say, my project and doesn't want to learn a single new thing, then I really don't care. My code should be safe, etc., and use proper C++ instead of for loops and trying to mimic Java or C. And I'm the guy that will teach the new people the meaning of all those things. And from my point of view, as a former university, whatever, my main aim was to teach newbies new C++ stuff, new development stuff, not necessarily to make contributors out of them, which is obviously a bad thing, but it is a good thing. It's a novel thing to teach people something, but we do love contributors. So I guess I had the wrong aim. But again, the main point was when somebody approaches, they try to do something, obviously, they send a PR that is really bad. Then you start teaching them, okay, you should use reference to const here, etc. And then they start improving, and in 2 or 3 years, they become really, really good contributors.
So you basically make them learn on their own mistakes.
Yep.
Kind of approach. Okay. Peter, how does it look like in your company?
Yeah, so there's a few things that we do. Like realistically, ideally, you would do what Ivan just said. You sit down with somebody and you teach them, but nobody has time for it. So we just force them to watch all Stepanov's videos. It works great. Like, you know, it takes like 20, 30 hours, 50. But they're much better after. So that's one thing. The other thing is, like we usually like to leave, you know, hundreds of comments for the first pull request because everything is bad. But after that, you know, they just stop coding.
And is there a way to basically enforce, I mean, not enforce, but encourage people to get interested in these modern practices without alienating the team? So let's say you want to introduce, you're deducing this type of code, and then how do you get people on board to use that?
So it's all about explaining to people what's the benefit to them. You know, like all of the things that we are doing and that you should do when you're modernizing code is to allow the actual developers to write code that is safer, more performant, and simpler for them. So concretely with deducing this, you in the past needed to write like these 3, or if you really want to be correct, 4 equivalent codes, and deducing this just helps them to write less code, which is faster and more correct. So they love it. But in our company, the way it usually works is you don't enforce it, but you actually demonstrate the value to the people, and then you spread it through, you know, one by one. Essentially, when you find somebody who's going to do it with you, and then you have this exponential effect where, you know, there's 2 of you, then 4, and etc.
So, in our case, in many projects, the level of liberty you would have to practice everything which is new, cool, and correct is maybe lower. So 2 practices I found useful when teaching younger ones is either some coding kata or what I recommend to everybody here, please create a hobby project at home. Like do something and then polish it to oblivion. Like, can you compress this file from 1,000 lines to 200 and they're still sensible and modern and so on? So if you have an itch you want to scratch, please do that. And if the project doesn't offer you that, then do it, you know, on your own time. But unless you feel a need for to solve a problem in this way, I don't think that any sort of learning is that much effective. Like people see, oh, there's this new function, there's this and that. Oh, and I forgot half of it because I didn't use it anywhere. So if there is some sort of a mini demo, proof of concept project at home, or a dozen of those, then people tend to remember because they tried, something broke, something didn't compile, something compiled then exploded, and so on and so on. So that would be my irish.
Yeah, so do you have any examples of how your team approached some type of modernization? Like, I don't know how long-lived projects that you work on are, but do you have some kind of a rule where, after a year, we have one person that goes through the code base and does some modernization, or is it like a Boy Scout, whenever you find something, go and fix it?
Okay, that's
Yeah.
Really depends from project to project. As I said, we are a service company, so we do not own it in many cases. I had recently a really nice opportunity to get a code base which was more than a decade old, and then to go with clunked ID and whatnot, and to push it from C++11 to C++20. And it was much better with a lot less silly allocations and many other things. So I wouldn't say a rule per se, but for example, code that old is immediately suspicious, either from lack of knowledge at that point, lack of standard features that somebody would use if they had it. So that would be not so precise but honest answer.
Yeah, and how long did that effort take?
Well, depends, few days, week or two.
Or that particular?
Well, yeah, because at one point you have a cutoff and say, okay, now it's not just cleaning, now it will be refactoring, let's say, like serious changing of interfaces and whatnot. But you can actually clean these sort of things like in a few days. I guess younger people would also use the dreaded AI daemon for that, but I'm still from the previous century, so wrong.
How big was it 2 days? It was done couple of days.
100, 200,000 lines, not more.
Okay. What all does it so they what itself like some warnings that were previously warnings and now they are errors or something like that, because that tends to be a hassle too, like buffing a compiler.
Yes, but mostly not because of C++. It turns out that many libraries change interfaces over decades. So something that compiled a decade or so ago now simply doesn't. Like function is not there anymore. So you need to fix that a priori. But in general, as I said, this is embedded world. We do not have 10,000 include. So if you have dependencies, it's like 3 or 4. So you can fix that. It's simply the nature of my job.
How is it done at scale?
Sure, you have to sell it first. So there has to be a reason to do it. And it's either the promise of informatic future teacher sponsor, or it will spend less resources or something like that, and then you get to do it. And it can take years. Not this project, the previous project we're on lasted for like 5 or 6 years to upgrade the whole code base, but they got 10x improvement. So
Yeah. Did you by any chance track these modernization issues in your preferred issue tracking system like Jira or something?
or paper. In yesterday, I can't remember what was the format, but basically it was performance related. So some performance test and then the output of that. But the issue is that no one's gonna let you refactor the whole code base at once. It's part by part, so the whole improvement is only visible after years. You can only like component based. That's that. So
Yeah. So you actually that's a really good thing that you mentioned, that you do need to sell it to management.
I mean, someone needs to invest money. So
Yeah, exactly. But sometimes, and I think you referred to that at the beginning, it's not just the managers that need convincing, it's also the developers, right? Like those.
Right.
So how do you approach that?
Convincing developers was already covered. You show something that is much better a long time ago. And again, this is something that you might bleep out. I had to work with Java code base. And at some point I saw a meme online that in some of the famous Java projects, they had an annotation that said, could have been one line in Haskell. So you have a huge code base and a huge function and annotation. This could have been one line in Haskell. And that's something that pulled a lot of people to Scala, for example, back in the day when it started getting some traction, because they saw I wrote 100 lines of something that can be rewritten in 5. Okay, this is clearly better. And that's the only way that I can convince somebody to switch to something better, to show that a certain bug cannot happen if you use this CDM or something, that you cannot make silly mistakes like less than or equal to n instead of less than, if you use ranges, etc., etc. So if you clearly show an example that fixes issues, then you might convince non-really stubborn people that it's better and that they should learn it.
Yeah, but I still feel like from time to time I still hear people that actually prefer to read a for loop, right? How do you go about that?
You're fired.
Physical violence.
Okay. So, like these are mostly the topics I wanted to cover for the formal, and now I want to open up the discussion to everybody. We can also maybe add a mic over if.
Rick? Yeah, I can use this one, right? I'm not sure if it's always convincing. By the way, in corporation working with Joe, right? So I don't think it's always convincing management. It's like more senior engineer.
No, it's not.
Yeah. Management cares about the bottom line or the features or whatever. The code base, you care about the code base. And they are great engineers who drive it, usually staff or above, right? Those are the folks like you, even in the open source community, those are the ones who set up the culture, right? And usually they want newer features like you do. But then there are a lot of people who don't really care if it's like really big workforce. So you can usually get modern features, but not everybody is going to use it. So that was my view on it.
Can you maybe, from your perspective, give how would you go about fixing that, encouraging people to use modern features?
Figure out who's the one who can say no to you, and then convince that person, basically. And that can be hard in corporations, right? So if you do that, then you're okay. But it really depends on person to person. Usually, I had no issues convincing people, right? So.
Do you think maybe like trainings or sharing the knowledge?
Trainings are awesome, but anytime we ask for like advanced CPP, we get modern CPP training that talks about factors and stuff like that. So I'm not sure about the trainings, but it kind of stems from the corporate or the company culture, right? So I think that's the best, the main thing, right?
Also depends who are you convincing. If you're convincing another developer, depends on who are you convincing. If you're convincing another developer, I'm going to advertise it. I'm in no way affiliated, but gold bolt, you can show it. Okay, this produces this assembly. If you're producing a product owner, it will take me less time next time to make this feature, and so on.
That's the thing.
You will pay less electricity for your data center if I make this change. So
it's a tailored approach to whoever you're doing it, I guess.
Yep. Next question.
Well, we were talking a little bit about tooling, but I also wanted to ask about specifically static analysis tooling. Like, because in my experience at least, static analysis tooling is kind of useless. Like it catches a lot of like superficial things, which like mostly stylistic for some reason. I have no idea why. And very, very rarely, like once in a year, we will have some issue in the deep graph analysis, like tooling, which is like, it will run for ages. Like we really can't wait for it to like maybe once a month, maybe we'll start to run on some slice or main branch and stuff like this. So like, what do you think about what we can do better? And like, you maybe know that in the committee there are some efforts to improve static analysis with some
guarantees. I have no idea what they talk about, but maybe what's your mind about this? Like, where's this direction of static analysis in C++ is going?
So this is just my perspective. Like, static analysis is great, but like, if you really need to depend on it, you wrote your types wrong. Like, realistically, if you really want to have code that's as close as probably correct as you can, you need to do it through types, and it needs to happen in compile time. Like, if you're having any things that are important to you that are depend on global properties of the code, it's already wrong. Like that's my perspective. So we do use static analysis. They usually have, false positives. In our case, it runs too long. It did help a few times, and it's great, but like realistically, I've always hoped for more, and we just transitioned to trying to type everything. And one major thing that I would say that is important to do is, so what people usually do, you have an error, you create an issue, somebody fixes it, and then you have the same error 2 weeks later. So instead of that, what really needs to happen is to actually sit down and understand what's the fundamental thing that's the problem, how do you express this through types, so that these kind of errors, the whole error class cannot happen, introduce that interface, and then retrofit the whole code base. And for me, modernizing code is actually doing that over and over again. And it's really driven by the actual development. So you see what's the concrete error that people are facing. You spend time understanding how to create an interface that cannot express that kind of error. And then people just start using it because they know how much time they spent the last time they needed to fix that kind of error.
To go on top of that, what do you think about contracts? Because you say that things need to be in compile time, and contracts is a new feature that actually introduces things possibly in the runtime.
So again, so contracts are great. They are expressive, they provide more data, they could maybe help with the static analysis part. But ideally, everything that you're expressing through contracts should be parts of the type. So if you really want to have a provable code, like the actual definition that you have in the contract should have been proven by something above the code. It's extremely hard to write this kind of code, practically impossible, at least in C++. So nobody's really actually doing it.
I wanted just to say, so for people who know him, whenever he presents some C++ feature at this meetup, it's usually, this is bad, this is all bad. So contracts, the same thing. The thing that I like about contracts is not the fact that they are checked at runtime, but that they might be used to speed up the static analyzers, which is not at all the reason for adding contracts to the language. But it might be a nice side effect that the static analyzer can say, okay, I'm able to call this function with argument 0, and that's an invalid argument. It doesn't need to delve into that function in order to find the bug somewhere else. The thing that I don't like about contracts, and I'll shorten the rant as much as I can, and all the safety talk in public with safe languages, etc., is that contracts by default kill your program if they're not satisfied. All the safe languages kill your software as soon as something illegal happens. Your software dies. Our software is not designed to crash at any point in time unless you're an Erlang or Elixir developer. So if you think that safety is crash this airplane down because there was a seg fault, that's not safety. And rent.
What was the original question?
You went so far. Static analysis. Static analysis. Over my career, I haven't found a good static analysis tool, there were almost all false positives. And at least in the corporate environment, it used to happen that it was automated to open over 100 tickets. And mainly, what this is, in my case, it was going mad over a thing that had plugins. So something that put dynamically low libraries couldn't get there, that's right. Yeah. So I haven't found anything that's told me this is bad and with static analysis. And other tools did help me, but never tool.
In my case, it's also very hard to measure how much client tidy, especially the one that runs per PR, you cannot measure how much it helps. Because in our company, we usually discover good things about client tidy once we upgrade to a new client tidy version, and then we discover, oh my God, we had so many issues, and then we actually found issues when upgrading from one version to the other. But a lot of the errors get fixed by developers because that's a part of our development process is running client tidy on each change that goes into the repo. So you don't know how many times it warned somebody and that somebody took upon themselves and, actually corrected the code while they were working on it.
I'm going to correct myself because I forgot the client ID is also a static analysis tool. I meant the corporate ones that are served by and stuff. That never. Client ID did. Yeah, sure. It's great.
Can I maybe add to that? I also like the formatters, especially again talking about corporate and too many or many developers or maintainers, right? Not everybody is going to be an expert, so enforcing a code standard also can help with some best practices, right? So, and formatting the diffs is a great way to do it. Clarity, stuff like that, right? Those I'm not sure how good they are. Security analyzers are also not great, but you have to use them, right? But what about ASIN builds or code coverage stuff? Do you use that? Because even depending on what your tests are, if they're regular unit tests, yeah, it works. But we kind of use them on functional tests, and that introduces a performance penalty. And running code coverage at that scale, it's challenging. Do you maybe use that? Or?
Yeah, so syntax testers are great. They're a really, really good feature that helps a lot.
Which one? I didn't catch that.
As all hedges like that, so each of them has value and I mean, it's a thing that when it helps, it helps. When it doesn't, you just ignore them. Yeah, running them on tasks and debug builds and stuff like that. I think that you should always do it because they just bring value. You're never going to run them on the optimized builds because no, you shouldn't.
I hope it falls into the area of the question. I had really nice experience with Valgrind and its cousin Helgrind. Well, I don't know if it's Helgrind is now maintained at all. It was many years ago, but in this regard, every single unit test ever should be run under this because we discovered first and foremost that we actually did have lack of devisualizations and also several bugs in libc library and so on. So you can also catch other people's faults from time to time.
Do you think that those tools help you move forward easier? Because like you said, you had code bases that were really, really old, decades old, and then you push them up to C++ 20. Did the tools help with that, and how?
Well, I would say definitely in that case, both Client ID and other tools that we mentioned here, they give you, let's say, you have some boundary, beyond this, it's simply stupid to go, so please go in. And for the memory issues, I would say this is a complete must. And again, a great argument for smart pointers and anything which avoids allocation. I also tend to be a person that has a deep-seated hatred for threads of any kind, if they're visible. So, and that's a long story, but whenever you can, please use what Linux offers and do not create your own threads. That would be like by default, but when you need to, please use normal tooling around it, because it's aside from memory, that's one of the absolute worst areas of finding bugs and figuring stuff out. So yeah, that's mini rant hidden in the answer.
No, I totally agree about the threading stuff. And I don't have a problem with threads, but like as long as they don't communicate between each other, they're great. Like those are no threads. They're perfect. I love them.
Well, and do you guys have any issues with any kind of third-party dependencies that lack your progress or modernization efforts?
Again, embedded world, it's Linux, C, C++, GCC compilers usually, and 4 to 5 normal libraries, let's call it that way. So no, maybe from the, I don't know if it's a code coverage or quality thing, I can maybe give an honorable mention to what happened in FreeRTOS a few years ago. They actually introduced on top of unit tests the, how to call that, mathematical provers. So you can actually have like these functions under these circumstances are when you run the prover, they mathematically prove that for these inputs, the output will always be this and that, or within that range and whatnot. So, and that's, I would say, a slightly advanced thingy. I'm not sure how much C++ is supported for that, but this is a university project. I forgot the name. And that's one of the cool things. But again, embedded world is peculiar. If our stuff doesn't work, we kill people. So standards around automotive, medical, and other areas are extremely rigid, and there's a reason for that. Otherwise, we would have airplanes hitting buildings every other day. So it's mostly around test coverage and other areas. But yeah.
Then why hate towards Misra?
Because how much can I swear? Let's say, and I will use analogy here as a father of 2 boys. If I don't want my younger kid to ever fall from a bicycle, I can, option 1, forbid him from ever riding a bicycle, and then like the whole problem is solved, and that's Misra. Option 2, like I can start teaching him and he falls from time to time, and then at one point he starts riding, and this is everything outside of Misra. So the problem, especially with Misra for C++, is that, and this is my swear word for the day, it literally castrates 80% of the language. Like you cannot use it. Literally, it's forbidden by the standard. And at that point, all the cool safety and let's say really correct mathematical parts of C++, which would make the code better, Misra guys don't understand, and hence it's forbidden. So my hatred doesn't come from the intention, it comes from the actual application. Misra C is, let's say, order of magnitude less annoying because C is simply a constrained language on its own right. But C++, there is simply like a big shocker. Like, oh, we don't understand how this thing works, therefore forbid. So that's the reason why. So if the stated reason was to make it safer through that, I object on the basis of experience.
Are any of you affected by the new EU regulative regarding
CRA?
CBON, like software, bill of material, things like that?
Sure, but more interesting that is Cyber Resilience Act, which is incoming.
Yeah.
And that is, especially for in the industries and embedded area, that's an extremely interesting area. And whoever of you wants to become an embedded security expert, now it's the career time. So, yeah.
Is that going to affect any kind of modernization efforts or no?
It's quite orthogonal, to be honest, and it's mostly in the area of secure practices, secure deployment, secure boot, encryption, certificate rotation, yada, 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 and covering every single vulnerability as soon as possible. So it's really a proactive immune system reaction of the bureaucracy of the Union towards the ever-growing market of embedded devices that are not compliant. Let's put it that way.
Is the tooling ready for that, or do you think
I think yes. I think I don't think we have, for CRA currently, I don't see any major vendor on the territory of Europe or North America lacking in anything. What we have is hundreds of companies that are non-compliant by default. So that's the thing. It's not the lack of tools, not the lack of knowledge. Like every single part of the standard is completely open. You can see it and it's very sensible, but we simply, can I go on a tangent?
Yeah, for sure.
Merci beaucoup. So embedded world or the automation world before that came from mechanical engineering, then electrical, then electronics, and then somebody put software several decades later there. And none of the previous three ever communicated with anything. So gears, pneumatics, hydraulics, they never communicated. All of a sudden you have a factory floor somewhere in Nebraska, which I can control from my laptop here in Serbia. And this is such a level of industrial espionage penetration potentially. That is something that we became interconnected many years before we learned how to do it safely. Let's put it that way. So now we are in the catch-up phase. So that's a tangent. So it does.
Anybody else?
To follow up a bit about on the type safety topic, I guess, like, okay, we want type rich systems, but how is your organization decides like how do we build this toolbox of types? Like, for example, if you move to different external clients, do you move like your own library with your own custom types? Like, because of course, like the standard provides us like shared pointer, unique pointer, but it's often not enough. Like that's why we have like GSL or maybe our domain specific things and things like this. How do you handle it in your team? If it's like a bigger company, do you have like a separate department which handles like toolbox type of things, like philosophical? How do you connect different team sites like between each other? Yes.
For my case, it's a service company, so we are really adapted to the client. So, and we usually work on their code and the way they do it. So, as a, let's say, a long-running mercenary, I do how people want me to do, but it's also my job to gently point them to better choice, simpler choice, faster choice, and so on and so on. But in the end, it's not ours. So my answer is then really, really useless. I'm simply whatever the other company is doing, and to the best of our ability to convince them to maybe move within this fiscal year.
So what I would say is, just have your stuff and just license to them. Like, it makes business sense, it makes developer sense. The problem is that you pretty much constrain yourself to only working on projects from scratch, which is fine. But like, actually, this is a more dull answer would be try to use standard types on interface boundaries. Yeah, that's probably the best way to do it. The standard isn't advanced enough for some topics to actually do it. That's pretty much it.
Okay. I have two questions, somewhat unrelated. The first is we've talked about random stuff, and one of them was airplanes crashing. How much do you actually bother making distinction between safety and security?
That's probably my question. A lot, actually, because I'd say safety comes in defending yourself from the environment, which is unintentional, fire, engine stopped working or something like that. Security is defending yourself from the agents, like something which has agency, human or an algorithm which wants to do something to you. I don't know if you have a particular sub-question, but I'd say anything that moves or heats anything is a potential killer of people, so therefore it needs to be safe. And usually half a decade or a decade later, everybody figures out it also needs to be secure, because if it's not secure, I can take over your gigantic truck and kill people anyway. So yes, these two are mostly orthogonal. There are situations where they clearly fight each other. So I don't know if everybody knows the safety security pack problem. Okay, yeah, tangent master. So let's say you have a gigantic safe in the basement of your bank with God knows how much gold and personal belongings and money and whatnot. And you have a gigantic door defending that. And, you know, when somebody enters that, this is locked tightly. When somebody exits, it's locked tightly. Now, if you have a fire in a building, which can reach the safe area, the safe thing to do is to immediately unlock all the doors to allow every single person to leave. Secure thing to do is to lock everything down so nobody can use the fire to rob the bank. And that's like an academic example of you cannot have both from time to time. So, and then, of course, in the more complex systems, you would then, of course, have a different fire protection mechanism there compared to the rest of the building and yada yada. But in general, yes, both of these two dimensions are well known for any single system architecture, especially embedded, and they're treated as such. Is this answering the question?
Yeah, pretty much. But my issue is more that when we talk about the language and language features or libraries and stuff, I think we use the word safety always, but most of the time it's actually about security. Although security does lead to safety, like if someone can hack your application, then he can kill you using it. It's just, yeah, how much I mean, this is actually a question for all four of you. If you care about safety and security, how much do you care about this distinction between safety and security?
I think I mostly answered. So.
Yeah, I mean, I think you pretty much covered it, but
I would say I wouldn't make a distinction in the terms of this is important and this is not. Both are equally valid. I would maybe put security under safety for a different thing, but the subject changes, but the same thing, you need to pay attention to the same things with your correctness and safety and, what did I say, maintainability. So you need to pay attention to all of those things in order to reach safety and security. I couldn't care less how you call them, just make your software high quality.
Sure. It depends. I would mostly agree with the guys, but
It's safety that you don't have to wake up at 4 a.m. So.
cool. Okay, so the second question, I mean, do you want to add anything or are we okay? Better, I mean. It's okay if you don't.
Safety is great, security is great.
Cool. Yeah, the second question would be, yeah, I think we we didn't really talk about the modern standards and stuff like that. But what would be one feature from any of the recent standards, is like within the last 10 years, so like from 17, that you would remove from the language?
such a political question.
Executors?
They're not yet.
Sure. See.
Executor?
No, but what are the standards from?
From each
No, like pick any feature that came out in last 10 years that you consider either useless or overused or whatever. It's just no point to it.
yeah. If it's useless, I have many of them. For yeah, most all, but like for me, like
Why would you modernize if you're a Google holder? The state, C++.
there's a reason why they say subset of a superset, you know, but like there's a lot of bad things in it. Like
For example, coroutines are really, really shit. Contracts are really, really shit. Concepts are really, really shit. Modules are really, really shit.
No, but coroutines are great, except they don't work there.
No, so the idea,
Async IO.
yeah, so the idea behind coroutines is beautiful. It's great. It heavily depends on the underlying executor model that's not standardized.
You're using them wrong. You're falling. So I just wanted to answer. I came up with something that people tend to praise as a safe thing that was added to C++, and it's added only because of safety, which triggers a lot of bugs in, let's say, things that are seen, and that's string view and span. Beautiful things meant to be used when you interface C libraries, and then you start using them for everything, and then what you have a reference type that looks like a value type. And obviously, dangling references with a value type is not something that I generally like. So I would remove those. So.
Yeah, I also wanted to add, like, I can't wait to see why I'll hate reflection, you know.
Because that doesn't have code generation yet.
No, that's fine. Yeah, like, I'm fine with the fact that something is not complete and it's going to be great in the future. But like the coroutines, they aren't trying to make them great. Like
We need somebody to make coroutines great.
make coroutines great again.
In defense of coroutines, I actually use them and they do work, except when you need to debug them and GTB is not up to the task. So that was my main because they're.
No, I'm just trying to, like, coroutines are great. You should use them. They're much better than anything we have. The problem is that they are not complete. You know, contracts are great. I would imagine once I see them. Concepts are phenomenal. They're just, you know, a decade late, and are incomplete and don't work well with Finaya, which is kind of important thing for them. What else? Yeah,
Well, that's one thing. I wouldn't remove it. I would just rename the shared pointer. Please rename the shared pointer to something that's like slow pointer.
A bottleneck.
bottleneck. Yeah, that bottleneck is a great name for mutex.
Yeah.
I have. So the question is like the opposite of the previous one. What features would you use to sell to your boss that you should modernize your code base? Like, you have an old C++ 90 whatever code base and you want to get it modernized, you talk to your manager and he says, convince me. So how would you convince him?
From 98 or from like
11 also.
Like from 98, I'll let somebody else answer. But for me, reflections is a really good thing that I can't wait to play with.
But that's in 26. But let's say
Yeah, it's 26.
for 23.
Deducing this. I think we already asked enough. What does your boss? What's your exact boss? Is it your manager or?
So you're trying to convince. I mean, it applies also to, like, we talk about modern C++, but we have legacy infrastructure. And I want to convince my manager that we should move forward. So
Is it a technical person or?
something in the middle.
Are you developing that software a lot? If not, then you need to tell them like it's gonna work faster, spend less of your resources, or I don't know, you'll get sued.
Yeah,
You don't
yeah, but
say-
what's the name of the feature? Like you can name several features, like shared pointers, whatever.
I mean, like you want what to exactly replace or
No. Like choose one feature from like you have a 98 code base.
right?
And you want to sell one feature to your manager to introduce. Which one would be the first one?
To the manager. Sorry, I misunderstood the question, but yeah, I think.
And it doesn't need to be from 98 to 11. It could be from
any standard, any other stuff. But the thing is, some of them are really interconnected, except for it's not, of course, it's not my unique pointer. But I mean, if you're going to use variadic templates, you also need the variant and stuff like that. So you can't just use one. I especially enjoy those. So that's what I will try.
You can say unique pointer and all connected features that are needed to implement it. So you would say unique pointer is like the core feature that solves your problem. You have a problem.
You ask me.
Then my manager says, "What kind of your manager? I'm your manager now. What kind of problem does it solve?"
Okay, so less code for you to maintain. It's automatic deallocation, so you don't need to write delete anymore, ever.
And why would that be a
You
problem?
need to release other resources because you can change the signature and it will automatically release the resource. It's not just for memory allocation, but it's also for resource acquisition. So, I mean, but that's just one step alone. They go packaged most of the time.
Yeah. What was your first feature that you introduced, Nicola? When doing that refactor, what was like the first step of modernizing the code base?
Honestly, unique pointers. So this is a pure recycling. No, but it's such a low-hanging fruit. Actually, thank you for mentioning it. It was already off my mind. I said, what was the other thing I did? But unique, that pointer is so omnipotent.
And after that?
The other thing, honestly, is aside from my burning hatred for threads, I actually really hate object-oriented programming. So therefore, templates. A bunch of inheritance in the older projects is there because there were no variadic templates back then. So once you start cutting these off, you actually also gain some performance. That's a weird thing because screw you vtable and whatever. And also the typing is now clear because some of these inheritance hierarchies, especially in the older code bases, have like 7 or 8 levels of interfaces and whatnot, just because at one point you have one random blob and the other random blob that needs to be in the same array or something like that. So these sort of couplings are completely unnatural. And my experience was that once we go from this type of object orientation to, okay, let's see the behavior of this. Can I treat it that way? That the code is easier and much more readable and more shallow. I actually like shallow code. Like if I see 7 levels of inheritance, like only God knows what the hell is going on. Like, and he's not helping today. So that's the answer. Like, you have something?
I just wanted to say lambdas.
Any more questions?
Just maybe additional like for range loops, because usually you don't, like when you suggest a feature, you don't just suggest a feature. You check like what are classes of errors you had in the like past year or two, and like loops often some error, like if statements often some error and stuff like this.
Yeah, containers, using containers across the board, so you can actually use range-based loops.
Ranges often errors because implementation is problematic for multiple reasons.
Okay, so thank you guys. Thank you so much for coming in. Thank you for all of you and to all of you, and let's continue the discussion over a beer.